Yeah, it's funny because every time I hear Adrian talk, I hate it because I always feel like I'm not doing enough. So I get like 6 months of busy work out of it. So, and it's been like that for years. I mean, I've seen his talks for years and years, and it just seems like I do all this extra work every time I see him talk. But it's cool stuff. I'm really glad that they do the open source. For those of you who don't know, we have a Cassandra committer that works at Netflix. So some of the code that's in Cassandra is, stuff that's real world experience in Netflix. So, this is part of the community effort that we have, open source. It's great. So our next speaker is Mark Davis. He works at Dell, but it's funny, we were just talking in the back. He was a co-founder of Katanga, which was then bought by Quest, which was then bought by Dell. So that's how he got there. But we're going to be talking about big data analytics. Thanks, Mark.
Thank you very much. And yeah, I just want to mention straight away that in terms of Dell, this is all part of a sort of a long-term sort of mission and evolution of Dell, where we began as a supplier of servers and laptops initially, and then gradually over time becoming more of a full-service enterprise software company. I'm going to talk about a lot of use cases and some high-level stuff, and then I'm going to talk a little bit about Cassandra at the end. Not initially, but there is some Cassandra in here. So first off, in terms of sort of high-level perspectives, some people have done some calculations and said, well, if you took all of the human spoken language up until about 1900, and you were to encode it at a certain rate, and how many people were they, and how often did they talk and communicate with each other and so forth, just broad estimates, maybe 10 exabytes, which is 1 times 10 to the 18th, as you all know. And then something happened, and that is our data generation began to expand and grow to the point where, as we all know, we're in the realm of big data technologies where we're confronting this edge. But one of the interesting uptakes about this is in terms of sort of the economic consequences of data. R.J. Gordon, who's a economist and therefore part of the dismal science at Northeastern or Northwestern, talks about the notion of industrial revolutions and the impact that those have had on the US economy. And so Industrial Revolution number 1 was fairly prosaic to our minds, but the invention of steam technology, steam locomotives and so forth. And with that, we saw an incredible disruption of traditional ways that people did things, and at the same time, tremendous economic opportunity. And that's sort of one of Gordon's themes, is that with technological change comes enormous disruption, but great opportunity as well. Industrial Revolution number 2 then happens with electrification in the United States, as well as something as important as telephony and running water and flush toilets. And this is kind of may seem, like a very basic thing, but there was a time where in New York City, the sanitation workers would march in parades and people would cheer them for what they had achieved in terms of liberating the city from the continuous stink of humanity. Industrial Revolution number 3 then comes about with the World Wide Web and the availability of portable electronic devices and their interconnectivity within that. And here we start to see an enormous acceleration of the data that's being generated. And we see technologies like Cassandra and other big data technologies become relevant as people began to outpace and outstrip the capabilities and sometimes the price of RDBMS and other technologies that had grown up around the same sort of time. And so for Gordon, now, this is the end of the line. He says, well, yeah, we achieved all this, but there's no major disruption that we can foresee in the future. And so he's, as I say, he's a pessimist. He's part of the dismal science of economics. But other people have said, well, maybe the big data revolution is really the next industrial revolution. And this has included dismal scientists like Paul Krugman in the New York Times, who has said, perhaps it is big data that is going to shape the unlocking of intelligent systems from the kind of brittleness that we've seen historically from artificial intelligence, and bring it on into a scale where it is effective in terms of being able to disrupt large numbers of low-level workers, large numbers of knowledge workers, and to replace them with machines. And so this is where sort of we stand today, and we're moving up into the zettabyte and the range at the moment in terms of the data. Some people say 2040, people like Ray Kurzweil, and this will be a watershed event, a singularity, and so forth. I tend to think it's probably a little later than that. But along the way, we have this kind of zoo of big data technologies, and these range from technologies, techniques, and ideas even that have come about, whether this is the notion of eventual consistency on the one hand, or companies that are involved in big data, as well as the confronting of different types of data that we've never really processed before, like unstructured data in the sense of raw text and blog posts and so forth, to extract sentiment, to extract named entities, people, places, organizations from it. And all of our customers are confronting the same kinds of challenges. How do they align the big data technologies with their future-looking business objectives, their current business objectives, and they're looking for guidance in terms of doing that. So a lot of what I'm going to talk about has to do with intelligent systems and use cases for them, but also data integration and how do you integrate data. For companies like Netflix, they have some data integration challenges, but they mostly have a volume sort of challenge. And so variety is perhaps less important. But what we find is that we have all of the different dimensionality of big data that's involved. So I'm going to talk about some use cases, run through a whole bunch of them, and just talk a little bit about how we help to solve them and some of the challenges that were involved in that. And then I'll wrap up. I don't want to do too much of a product pitch, but just talk a little bit about my company, what we created, and what we're moving forward in terms of integration with the entire Dell capabilities. So we got our start in around 2008 as Catenga, and our primary customers were in the US government, and they were focused on defense intelligence. The goal for them was to improve force effectiveness, and that meant when Humvees roll out in the conflicts in Iraq at the time and then into Afghanistan, and then the officers come back and they write an after-action report on the day's activities. In order to do this sort of thing, they write narratives, they have semi-structured data, the locations, information of that sort, who was involved, and who they encountered, what the day's activities were, if there was any kinetic events, which is the polite way of saying that the gunfire was exchanged. And they record all that material. But in order to make use of that then down the line, so that as I'm doing mission planning later on, I want to know what to expect as I enter a village, what to expect as my Humvees roll down a road, and how to essentially turn that into actionable intelligence, we need to do different things to that data. That is, for the narrative fields, we need to make it searchable. We also would like to extract named entities from that using natural language processing to be able to extract the names of the people that were encountered, the people who were involved, the locations that were encountered, and the different types of interactions that occurred. And the end goal is to help prioritize and understand threats as well. And so we kind of use this sort of roll-up starting from the bottom here in terms of this visual representation, that you have source data coming in, and that goes through an intake funnel, and we extract from it metadata, and we enrich it with metadata that reflects who is doing what to whom, and where, and why, maybe, as well, all from within that same stack. And these kinds of intelligent information processing tasks tend to be fairly heavyweight. as you can imagine. And so being able to distribute that load over multiple machines in a big data sense is a critical part of that. And then on top of that, we want to provide tools that don't just populate sort of templates associated with this data, but make it visually understandable. So in terms of our initial use case, we were working with US Army Intelligence, the I2WD, which is the Intelligence Information Warfare Directorate. And the system that they had for many years did not scale. They were overwhelmed as the Army encountered more and more engagements in more and more theaters. And they needed analytic capabilities that merge with search, all in the same environment. So there's one use case, one of our primary use cases initially, but the same theme can be applied in sort of different realms. For example, in competitive intelligence, we wanted to change R&D priorities and improve marketing approaches for a major Silicon Valley company. They want to be able to look at their competitors' information, white papers and material on the web, be able to extract what they're doing with DDR3 memory and things of that nature, to crawl websites, and to be able to make all of that information actionable at some level. And so for a technology company, we created custom natural language processing capabilities that do things like extract the names of flash memory, memory types, electronic devices, and so forth from the mass of their websites. And we actually found for some of the companies we were working for, they were surprised that there was that much material on the web. So it was a big surprise. Great, bind all this metadata now, and this is critical in terms of reaching the end user, the business analyst, and the line of business decision maker, binding all that metadata and capabilities into a visualization capability so that they can interrogate the data, they can drill down, they can understand the factors that contribute to the way in which the data is presented, and so that they can make better decisions. Drug discovery. So we're moving far afield now. We've gone from military intelligence to competitive intelligence. For drug discovery, the same sorts of themes occur. Published research reports, genomics and whole proteomics databases. We want to be able to extract what are the compounds that are involved, what are the drugs and the downstream biological consequences of those drugs as they are metabolized throughout the human body and so forth. And this means taking a look at different data sources, and data integration turns out to be an enormous challenge. We initially were working with a MD, PhD in Stanford School of Medicine, who was working on a certain type of stroke that can occur in human brains. And she said, please save me from having to integrate information in Excel spreadsheets, because that's what she did most of her time. She pulled data in from resources like NCBI and proteomics data sets and just spent all day trying to map that data together. And so the ability to take all of this different types of variegated data and to be able to pull it together in a rational way and then to be able to make sense of it at some level. And so one pilot POC that we did was for FDA. FDA had a basic search capability that was exposed internally. You also can go to the www.fda.gov site, and you can do a basic keyword search presenting ranked list of results. And it's a very simple page-through sort of thing. One thing that they found was that internal regulators could not access drugs by their regulatory number, what's called the NDA number, their accession number. And that was due to the fact that a lot of search engines take numbers and throw them away before indexing. And they do that because numbers are very productive, and they would pollute the database and or the index for the search engine, and they would have index bloat, and nobody wants that in their search index. So they threw it away, but that meant that nobody could figure out where in the regulatory pipeline any of their the drugs were. And so by using natural language extractors, we were able to extract patterns that included things like NDA numbers. What is the status of the drug in the regulatory pipeline? Is it approved? Is it in recall? And so forth. And bind that into a interrogatable and search resource so that you can now see at a glance what are all the ingredients in the drugs related to that contain acetaminophen, and what is their status in the regulatory pipeline, and what is the company that manufactures them. And CRM Analytics, this is a ongoing work that we're doing with a major telecom provider. Your sources are customer relationship management records. They're typically in narrative fields. Despite as much training as you could possibly give to call center people who are escalating calls in about their service and their phones and so forth, they're going to write things in idiosyncratic ways, and it's going to be difficult to extract meaning from it. But the goal is really to normalize and extract some sort of value out of it, and to provide the ability to drill down on that. And these records for a large telco provider are typically not used in any way at the current moment. They fall on the floor, they are recorded, and oftentimes there's a Hadoop cluster that's being used to dump that data, and sort of the notion of the rubbish heap of HDFS, but very little is done with that data. Network analytics, this is a canonical use case, of course, for things like Hadoop and Pig, being able to pull data together, Cassandra as well to a degree. And we worked with a router switch vendor who revealed to us that in order to understand network failures and manage network switches and devices, they did not have sufficient Oracle capacity to store the data, and embedded analytics was too slow. And so they had a Tiger team halfway around the world that would dump the entire database, and they had a library of Perl scripts that they would run across the database dumps. So that was a bit of an eye-opener for us. And I'll just mention a couple more. I want to get to showing you rather than describing you. And I usually do a live demo, but I don't have that option today. Buy signals, this is a classic sort of use case associated with targeting sales and doing recommendations associated with products, and crawling and extracting sentiment associated with Twitters, blogs, websites, and things of that sort. How do you make use of that data once you have acquired it? What is the output that you're providing in order for people to make better decisions? Sometimes it's a statistical outcome, but oftentimes it's a discovery process where people are using visualization tools combined with search to be able to drill down on that kind of data. And there's more use cases around here. So in terms of my goal with this talk is how do you make use effectively of big data? I just want to, and in terms of your cluster, to kind of germinate some seeds of thought about these kinds of use cases. The companies that are involved in big data and as part of their line of business, they understand what they're trying to achieve, and a lot of you understand what you're trying to achieve. But for the broader enterprise world, they're still sometimes struggling to understand how to make use of these technologies. So just do a brief introduction, and then we're going to be out of time here, I think, to the Cassandra Analytics suite, and show you a little bit rather than telling you what we do with the data. So we're primarily a Hadoop-oriented platform, although we have a connector strategy associated with Cassandra, and of course with HBase and our DBMSs and all of the different ways in which the data can be provided. However, we got our start working on top of Hadoop, and so batch-style analytics. And our goal is really to transform big data into actionable intelligence, and that means being able to do things like aggregate and count things. That's clearly a critical use case associated with big data. But where we really kind of differentiated ourselves was by providing intelligent systems on top of that, machine learning and natural language processing, and then binding all of that metadata that's generated, whether it's a classification of blog postings or it's extracted people, places, organizations pulled out of data, whether it's sentiment that is acquired through a combination of understanding the adjectival structure that people use to describe products and so forth, with some sort of noise curation, if you will, by using machine learning on top of that. All of that becomes metadata then that exists in addition to the original data. And it's sort of this combination of metadata and the original data, and turning that into a search and analytic product that we're really trying to achieve. And that means that we have visualization tools like charting, graphing, and modeling and visualize capabilities. A lot of them built on open source foundations and expanded, and then binding to search results, as well as Hadoop distributed file system results and Cassandra as well. And the goal really is to ultimately to help our customers to better predict the future and sort of understand the past. So we talk about two users of our technology, and we found that this sort of resonates with almost any technology that's trying to achieve analytics over big data. So on the left, is that stage right? We have the analytical producer. And the analytical producer is the data scientist. It's the business intelligence person who's been tasked with performing data science. But it's somebody who needs to take big data resources that they've perhaps never used before to try and get some traction on and produce an analytical product out of it. And then on the other side, we have the analytical consumer. And that's a line of business decision maker who needs to take the results of those analytical products and be able to make a decision out of it. And so we have capabilities in this kind of Mickey Mouse Venn diagram here that range from analytics, including some of the features that I talked about, natural language processing and machine learning. We build on top of Hadoop. All of our pipelines and everything work across Hadoop. We have visualization capabilities, and then search that goes beyond the rank list and really binds faceted visualization directly into the search experience. So what does that look like? Well, so here you have an example of how to create a workflow, and the workflow is doing some extraction of HTML links and HTML text. We have a variety of tools that you drag and drop onto a stage. You wire them up, you parameterize them, and you configure them. You press the go button, and it operates over Hadoop, moving the data from the data source into the Hadoop cluster, and then ultimately producing results out of it. You can monitor the process as it flows over the Hadoop cluster, and watch your cluster as it takes on map task and reduce task, and ultimately dumps the result out. We're not really a heavyweight enterprise, thousands of node Hadoop monitoring tool. Some of our the infrastructure providers for Hadoop do a very good job at that, and so we just provide this in terms of the analysts being able to see what's the status of what they do. And then ultimately be able to bind in an intelligent way to that data as it lives on HDFS or within the search interface context. And what do we mean by bind intelligently to that? Well, we may need to, in generating a geospatial visualization, we need to do some sort of intelligent geospatial name disambiguation. And so we take a term like London, and it turns out there's a London, Ohio. San Francisco, I believe there's 10,000 San Francisco mentions in Latin America alone. How do you rank those and provide the ability to filter down on it to be able to provide the visualization that you want, whether it's by population level filtering or country level filtering and things of that sort, to provide the ability to bind these visual tools directly to Hadoop data, and to shorten essentially that data science workflow cycle where you ramp up a team, they have an analytical product task confronting them, and they have to assemble the expertise and the tools, and then they ultimately have to bind that into some sort of visual representation for the line of business decision maker. And then, in addition to that, we have a search-driven capability that combines, and some of you will recognize some D3 in there if you're from the open source community, that binds visual tools directly into a search experience. So when you start to do a search, now all of the metadata gets populated into different visual tools, and you can see some very interesting outcomes. You can see essentially what the lay of the land is with regard to your search results. If you do an initial query on one term, and then you get a visual representation. And I go back far enough, and I have a few minutes, I think, that I'll just mention an anecdote about this. This goes back to the early days of information retrieval research in America in, say, the 92 to 95 range. And Sue Dumais, who was later my boss at Microsoft Research, did a study where she found that if you put people in front of an information retrieval system, and at the time, information retrieval was only of interest to librarians and spies, hardly anybody, there was no web. If you put them in front of that, and you ask them to guess at their search terms and start typing and so forth, that their ability to use the search engine was directly proportional to their SAT verbal scores. In other words, their ability to guess words was proportional to their verbal fluency. But what she found was that if you provided more like this context, something as simple as you do an initial query on Saturn and you get cars and you get some documents on planets and there's a lot of ambiguity, how do I change my query? That if you just say, well, just click on the one that you think is nearest to what you want, then that difference goes away, that individual difference where users are no longer constrained by how much verbal fluency they can drum up in support of their query task, but are instead capable of using tools like this to discover information in a broader sort of way. And so that's just a little anecdote as to sort of the power and the why of going from a ranked list result to other tools that sort of fulfill a broader agenda associated with data interaction, to look at the geospatial layout of search results, to look at the companies mentioned within search results. Here, in this case, we're looking at thousands of tweets and Facebook postings that have had their sentiment analyzed, and we're binding into a visual representation, sentiment-bearing terminology in the middle, and topic areas over in pie charts and so forth, so you can drill down on it according to what your needs are. And this sort of expands on that, and we can see here the use of heat maps and other visual representations to be able to expand and enhance that. So just to finalize, and don't know how long I have. Is anybody monitoring that? Couple minutes? OK, great. I want to touch on Cassandra, since we're here at Cassandra Summit, and how we're integrating into with Cassandra. And it turns out that Dell, and its wisdom of purchasing Quest, and Quest purchasing us all within 5 days, I should say, and my head's still spinning, has a product called Toad Intelligence Central, which allows the capacity for doing these kinds of data integration tasks to map different schemas across NoSQL, Cassandra, and our DBMS resources, to materialize that in a view, and then we can drink that in. We can target that to move it to other platforms. But the way we're using it is that we have the ability now to mash that up, Cassandra, with, for example, user login information, with crawls of the web, with crawls of feeds of social media, and to be able to get a 360-degree view of the combination of internal data and external data, all using this sort of zoo of different technologies that has been coordinated in terms of its ability to pull that together. And with that, I'd like to thank you and send you off to your lunch.